Hello and welcome back. In this session, we are going to add intelligence to our bot and we are going to use Azure's LUIS Cognitive Services to achieve that. We are going to see how we can create intents and entities in our LUIS application. In section 2 of this course, we saw how we can create a Azure account and then create a LUIS app. In this section, we are going to move forward on that and then see how we can add different intents and entities using different utterances. And then we'll see how we can train our application and then publish it and then use it with our bot. We will also see what are the different kind of endpoints provided by LUIS, and we will also see how we can use those endpoints by taking up few examples. In this flow diagram, you can see we already have activity handler created, the RR bot or the main dialog. We are going to create LUIS recognizer in this section and then use that recognizer to make calls to NLP API or our LUIS app API, which is going to provide us with a intent or one of the topics, and also it will provide us with a prediction score that we can use to route our incoming activities to one of the underlying component dialogs. So what is language understanding intelligent service or LUIS? We've already seen a little bit about LUIS in section 2 of this course, and we know that LUIS is a cloud-based API service that applies custom machine learning intelligence to a user's conversational or natural language text to predict overall meaning and then try to pull out relevant detailed information from that, like entities and intents. Using LUIS in a chatbot is pretty easy. Once you have a working LUIS app trained and published, then you can send utterances or text to LUIS from your chatbot client application, and the natural language processing endpoint API will receive this utterance and then gives back the results as a JSON response. That JSON at the minimum will contain a query that we are going to send from the chatbot client, and then as per the trained model, we are going to get a top intent which we can use as a topic, and then also we are going to get a score for that particular intent. A score can be seen as a confidence level of LUIS app, which says like how confident it is in predicting this particular topic based on the incoming query. And then if you have some entities built into LUIS, it's gonna send back entities if any are found. So you can create 3 different kind of models in LUIS based on the data you have, based on your business requirement and the data that you have. There are some pre-built domain models which are readily available in LUIS that you can just include in your app and then train and publish them and then use them. Or you can create your own custom models that you will build based on your own utterances and intents and entities. Or you can use a mix of both pre-built domain and your own custom model. So there are 2 ways which LUIS provides you to create your own model. You can use authoring APIs. Authoring APIs are those that you use to create your model and then train your model or modify your model. Or you can use LUIS portal to train your model or create your model. We are going to use LUIS portal in this course to train our own intents. And later on we will also take few examples and see how you can use authoring APIs to achieve the same. Besides authoring APIs, LUIS also provides you a query prediction endpoint, or you can say natural language processing endpoint API. This is the API that your app or your chatbot client is going to use, or your bot is going to use to query with the user message and then get back a response. So let's go back to our LUIS portal and start building our intents, entities, and then train and publish it. So I'm back to my LUIS.ai portal and I've clicked on my apps section, and here I can see the RR bot application, the app that we created in section 2. Let's click on RR bot. It will take us to RR bot's dashboard. So right now you can see that we haven't published anything yet. There are no endpoints available, and that's why there are no endpoint hits. Let's go to build section. So by default, when you create an app under LUIS, you will get a none intent, and then on top of that we can start creating more intents. Let's click on create new intent. I'm just going to create a new intent and call it make reservation. So we are going to create the same topics that we previously built. We hard coded the topics and use the switch case to route our incoming user activities. But this time we want to use the same topics, make reservation and cancel reservation, and then use Louis NLP API to fetch the topic instead of just matching the text in switch case. So let's go ahead and create it. So intent has been created. But for our intent to actually work, to be actually able to understand the user intent, we need to give some example utterances, because an intent is used to classify user utterances based on the user's intention. So in our case, we are using a restaurant reservation bot, and users can have intentions like make reservation and cancel reservation, or maybe modify a reservation, or it could be just something very random like get the restaurant address or what kind of cuisines are served in this restaurant. But for each intent, we need to provide example utterances to teach Louis about what kind of utterances should be predicted for this particular intent. So let's go ahead and add some example utterances for make reservation. You can just click on the text box here and giving example utterance. Please make reservation for, let's say, 10 people. Just press enter and that utterance will be loaded under our intent. Let's another example. This time let's say I want to book a table for 5 people. This time let's say 5% and press enter. In the same way we can add another example. Let's say, oh, I made a mistake there. I'm just gonna edit it. To edit your utterance, just click on the checkbox and then click edit. I want to book a table and then again press enter. Similarly, I can add another utterance. Let's say create reservation for 4 people. And then press enter. In the same way, I'm going to create another intent for cancelling our reservation. I'm just going to call it cancel reservation and then press enter. And then we need to provide few utterances. This time I'm going to just type please cancel my reservation, or I can say I want to cancel my booking and press enter. And that's it. So here we are adding few utterances for demonstration purposes. In a real world app, we should have at least 15 utterances of varying length, word order, tenses, grammatical correctness with punctuation, and a different word count. Also, it is advisable to add similar count of utterances for different intents under the same app to get the best and accurate prediction. Also, we have a default none intent in our app. So the client application needs to know if an utterance is not meaningful or not related to application and does not pertain to any of the topics that the bot is supposed to manage or handle or serve. So all those utterances that are not related to our app should be put under none intent. And then later on, like if a user queries something unrelated to our bot, we can train or build our bot in a way that whenever Luis returns a none intent for an utterance, your client application can ask if the user wants to end the conversation or give more directions for continuing the conversation. And if you leave the none intent empty, an utterance that should be predicted outside the subject domain will be predicted in one of the existing subject domains. So by default, if nothing matches and you haven't trained your none intent, then Lewis will incorrectly gives back one of the utterances, one of the intents that we have trained, like make reservation or cancel reservation. So let's go ahead and add some unrelated utterances under none intent. I'm gonna click on none intent and then just type something very random. Let's say barking dogs are annoying, and then I'll just type sharks in the ocean. That can be something really unrelated or random, but we do need to provide some intents here. So if you notice, I'm keeping similar count of utterances under none intent, and that's it. Now let's see how we can create few entities in our intents. I'm going to click on entities. So an entity defines a data which needs to be extracted from within the utterances. So whenever the user types in a message, that message can contain some unstructured data that we need to extract and use it as entities, or use it somewhere in our waterfall models or dialogs to do some business logic. So all this data comes under entities. Now in our case, we are going to create an entity to define number of participants. I've kept the type as simple. There are other types that are available. So that's how you can create a simple entity. But the important part is how you can use it. So I'll go back to intents. I'll go to make reservation. And here you can see when the user is typing in an utterance, he's giving the number of participants count in the message itself. And if you want to extract this message, and we do not want bot to again prompt the user to get the same information, which is number of participants, we can simply train our intents to fetch this data by turning them into entities. So you can just simply click on 4 to a left click and then click on number of participants entity that we just created, and you can see that particular number 4 is turned into an entity. Similarly for 5, click on it and turn it into an entity, and 10, just define it as entity. Now there could be case when user does not really type a number 4 in number format. The user might type into words. For these cases, you can use phrase list, where you can define sort of like different synonyms that you can use. I'm going to name this phrase list as number of participants, and then you can put a lot of different comma separated values. I'm going to put 4, 5, 6, and I'm just going to put 4 and then press enter. So you can see it has fetched numbers and then the word 4 here. And if you click on recommend, they will also recommend you the similar words that it found in the dictionary. So you can choose few more items from there. Let's add few more. 6, 7, 10. And now you see if you click on recommend, It's giving you more options in the Word format. You can click few more. And then click on done. So we just created two intents and we added some utterances to the intents. And then we created an entity called number of participants. And then we label the text representing the entity in the example utterances within the intents. Right now for demonstration purpose, I'm just using make reservations, number of participants, entity. Now these labeled examples will teach Louis what the entity is and where it can be found in an utterance. We'll see how it works once we train and publish our app and then test it. So let's go ahead and train our application. So you can go up and click on the train button. This will start training our Louis app. So our app has been successfully trained. Now we need to test our app before publishing it. So let's go to test. And here you can type any utterance. So I'm going to type please make reservation for 10 people. And there you can see you got the make reservation intent with a score. So if you click on inspect, you can get more detailed information about the response that we have got from Louis. So again, you'll see the top scoring intent is make reservation, and we got a confidence score from Louis, which is 0.95. The confidence score is between 0 to 1, so a score of 0.95 is pretty good. Under entities, you can see the text 10 was captured as number of participants. So this was the entity that we defined, and it was successfully captured by Louis. And so once we call this NLP endpoint from our bot, we are going to get the similar response in JSON format, and we will use make reservation as our current topic, and then use number of participants value as 10 directly in the waterfall model, and we will skip that particular step where we are going to ask the user for number of people that are going to be at the restaurant. So our testing is complete. Let's go ahead and publish our Louis app. Just click on publish, click on production, and then click publish. You can just click on the list of endpoints that has been created after publishing our app. And there you go. So once you have published your app, you will get a starter key by default. But this key has some limitations, so I'm gonna add another production resource for our RR bot. You need to select the tnet. I have just free trial, and then you have to select the resource name which we have just created, or the resource for which we need to create a new key, and then click on assign resource, and this will create a new key for you. So here you can see we have RR bot resource created for us with a new set of primary and secondary key, again under free trial. And then you get a example query that you can use to make a quick post call with a query string attached in the end, and that should give you a prediction score along with the intent. There are always two keys provided by Azure for any prediction resource, and this is done to make rotation of keys easy for you in your application. So when your primary key is expiring, you can switch to your secondary key and then rotate your primary key. And similarly, when your secondary key is expiring, you can add your primary key in your application and then rotate your secondary key. So let's go to our Visual Studio Code. So till now in our dispatch to intent async method, we were just matching the incoming text which the user was choosing in suggested actions method, but we didn't have any intelligence built in our bot, and the bot was not able to predict the intent, or and the bot was not able to get the intent of the user. So let's go ahead and update our code to add the intelligence. So to be able to connect to our LUIS natural language processing API, the prediction API, we need to import the LUIS recognizer, which is provided by a bot builder -AI module. So I'm gonna just initialize the LUIS recognizer, and then we will initialize the recognizer in the constructor method. So let's just add it here. I'm just gonna copy paste the whole block. So I'm gonna call it dispatch recognizer, and we are going to use the dispatch recognizer to connect to LUIS app ID using the LUIS API key that we just created, and then we are providing the endpoint where our LUIS application is hosted, and then I'm putting in some parameters in the configuration which will enable us to include all the intents that LUIS will predict, including the top intent. We don't need this, so I'm going to just remove it. In the next step, we need to define these environment variables in our .env file, because we are picking up all these credentials from the .env file. So let's go ahead, go to .env file, and then add all the three variables. So let's add all the variables. I'm gonna pick up the app ID from the example query string. And let's pick up the primary. You can use either primary or secondary key. I'm gonna pick up the primary key. And then our hosted zone is West US. So I'm going to just put West US here and then save our environment file. Let's go back to our rrbot.js file. Now we actually need to use dispatch recognizer that we just initialize and connect to LUIS app and fetch a result for our incoming message activity. So now let's just create a variable called LUIS result, which is going to save the result which will fetch from our LUIS app using dispatch recognizer we just created. This is going to be a async function, so I'm going to call recognizer method of dispatch recognizer object that we just created and pass the context. And then I'm going to just put a console.log to display the result that we will receive from our LUIS app NLP API. Everything looks good. Before we start our bot and try to test it and see if our LUIS recognizer is working properly and fetching the intent from NLP API, let's just install the bot builder -AI module that we just added. So our package is installed. Let's clear the screen and try to start our bot. Our bot has started successfully, so I'm gonna go to emulator and then restart the conversation. So we are presented with suggested actions welcome message. I'm gonna choose make reservation and this time we should see some result from our Louis API. So in the result we got from Louis, we can see that the make reservation query or this text message was not understood by the Louis model that we just trained, and that's why the top intent has been given as none, that too with a very low score. So let's go back to Louis and add this query make reservation as a part of the utterances under make reservation intent, so that our Louis application is able to understand this query. So Louis provides you with a feature called review endpoint utterances. Let's click on that. Under this feature you will see all those utterances that were sent by the user to our bot and were not understood by our application, and that's why they are put under here for review. So you can just choose make reservation query that we just sent and it was not understood by our Louis app. I'm gonna change or align this particular utterance to make reservation intent and then click on add button. Now if you go back to intents and check make reservation, you will see that make reservation query has been added under make reservation intent. So after every changes we make to make reservation intent, we need to train the model once again. Let's train the model and then try to test it. Similarly, I want to add cancel reservation utterance under cancel reservation intent. So that later on when we test cancel reservation option in welcome message, our bot will be able to predict the correct intent. Let's train it once again. So model is trained. Let's go and test it. Let's test make reservation first. And there you go. This time we got a make reservation intent and then we got a very high score of 0.88. We didn't have any entities, so nothing has been predicted here. To make this latest trained model available to NLP API endpoint, we need to publish it. Let's go ahead and publish this model. I'm going to choose production and publish. So publishing is complete. So let's go back to our emulator and test the latest changes. I'm gonna reset the conversation and click on make reservation. Let's go to Visual Studio Code and check the console log for Louis' result. So now you can see the top intent is make reservation with a score of 0.88, and based on this score we can use it to route this particular topic to our make reservation component dialog using the dispatcher function. Similarly, let's go back to emulator and test for cancel reservation topic. I'm gonna restart my conversation and then choose cancel reservation this time. Now this time from the Louis result we should get cancel reservation as the top intent. Let's go to Visual Studio Code. Let me expand it a little bit, and in my latest output I can see that Louis has given the top intent as cancel reservation for query cancel reservation, and the score is 0.644. So using the proper training, we are able to accurately identify the topic or intent of user, what the user wants to do. So in the next step, we need to replace our hard-coded values that we were using earlier in our dispatcher model or switch case to the intent we are getting from Louis. So now we already have the Louis result. All we need to do is fetch the top intent from this result. I'm gonna define another constant called intent and then call the top intent method of Louis recognizer object and then pass the result we just fetched. So this intent constant will contain values like make reservation and cancel reservation, whichever is the top scoring intent. And then we want to use this value in our dispatcher function. So first thing we need to do is pass this value, the value of intent that has been just captured, to our dispatch to intent async method. Now in the next step, let's go to dispatch to intent async method. Here we need to capture the variable. I'm gonna name it intent that we just passed from the onMessage listener method. In the first if case where the intent name or previous intent name is already present and there is already a dialog going on, we don't want to change anything. In the second case, when the dialog has ended, we want to change the context activity text value, which we hard coded earlier, to the intent we are capturing from Louis app using natural language processing. And in all the other cases, when there is no previous intent present, I want to set the current intent to the topic we just captured from Louis result. And again here we want to set the previous intent value to intent. Everything else looks fine and all our previous code should work. We have successfully switched from hard-coded topic values to our Louis generated intents. I'm gonna clear my bash shell and then start our bot. So one important thing that we need to remember is that our intent should not contain any spaces, and if we have added intents in our Louis.ai application, so all the spaces in those intents will be, in those intent names will be converted with an underscore. So I need to change the cases and put an underscore between make and reservation wherever we have spaces, and then let's clear the screen in our bash shell and start our bot. So our bot is up and running. Let's go back to emulator and test it. I'm gonna restart the conversation. We have the welcome message with suggested actions. I'm gonna choose make reservation, and this time we should be taken to component dialog called make reservation with waterfall dialog initiated. So let's see if it works. And there we go. So we have successfully switched from our hard-coded topics in switch case in our dispatch function to Louis application, which uses natural language processing, and we have added some sort of intelligence to our bot. So if we move on and press on yes, everything should work as it was before. I'm gonna put 34. Let's put a random date. See, if you put something else, it's not able to recognize its time. So I'm gonna put 12 a.m. and then we have successfully captured all the values with date and time. I'm gonna choose yes. So you can see everything worked fine. We got a reservation ID and then again presented with a suggested actions message. And if I choose cancel reservation, we should be taken to cancel reservation component dialog. And there you go. So we have everything working fine and we have successfully added Louis to our chatbot. So in the next step, we will see how we can use Louis entities and try to make our bot a little more smarter and user friendly. So let's go back to our Visual Studio Code and use our intents and entities together. So I'm back to my rrbot.js file, and inside our onMessage listener, we need to define constant for saving all the entities that we have just received along with the Louis result. I'm just creating a constant called entities, and then saving entities from Louis result into this variable. Now, to be able to use these entities in our waterfall dialog, whether make reservation dialog or cancel reservation dialog, we need to pass these entities to the run method of make reservation dialog when we will initiate the dialog for the first time. So we need to pass this to our dispatch to intent async method, and then let's go to the method, and then we need to capture the newly created entities parameter. So all our entities are available inside this method. I'm gonna go ahead and then while calling the make reservation dialog for the first time, I'm gonna add the entities as a parameter in the run method, and that's all. Now let's go to make reservation dialog and make the changes in the waterfall steps. So I'm in my make reservation dialog.js file. Let's go to the run method for this waterfall dialog. We were passing the entities parameter from our dispatch method, so I'm going to capture those entities. And in the next step, what we need to do is, once this run method is called and we've created the dialog context and we are ready to execute the waterfall steps, we need to pass these entities to the first step of our waterfall dialog, so that we are able to identify and save if any value for a number of participants were saved. So we can do this by passing an extra parameter in begin dialog method of dialog context object, and all this data that you want to pass to waterfall dialogs can be added here. So I'm just gonna pass the entities variable that we just received. So inside the first step, we want to check and save if number of participants value was received. So I'm going to save the number of participants entities that we have received into step.values.number of participants variable, and to fetch this value, the entities value from the data that we are passing in begin dialog method, we can use step.info.options variable and then give the name of the entity array. Now let's go to number of participants step. So we are going to present this number prompt for number of participants only in case when we haven't received any value for number of participants from entities. So we need to check if step.values.number of participants does not have any value, it's a null value, then we are going to send this prompt. Otherwise, I'm just going to continue with the waterfall steps, and to do that you can run the continue dialog method of step context. So if this value is present, then we are going to just skip this particular prompt and then move on to next step. In the next step, we want to save the number of participants value from the previous step only in case we didn't get it as an entity. So I'm just gonna copy the if case and then paste it here, and then the subsequent steps going to be same. Let's save our code and start our bot. So our bot is up and running. Let's go to emulator. Let's restart the conversation, and this time I'm going to type in please make reservation for 5 people. So as per our training, our Louis app training and the entities that we have defined for number of participants. This value 5 should be captured as an entity under number of participants. Our bot should pass it on to our waterfall dialog, and number of participants step in the waterfall dialog should be skipped. But in the end, when the waterfall dialog presents a summary of all the values, we should see this value captured. So a waterfall dialog has been triggered. Let's press yes. Looks like I made a mistake somewhere. Let's go back to our Visual Studio Code. I put in the wrong method name. This has to be continue dialog. Let's save it. Let's clear the bash shell and then start our bot once again. So our bot is up. Let's go back to emulator. Let's restart the conversation and quickly type in the same message. I pressed yes. Let me give a random name. And this time you can see the number of participants step was skipped, and the waterfall model took us to the date step, which was the fourth step. Let's put a date. Let's put a time. And that's it. There you can see that even though that waterfall step was not presented, we are still able to capture the entity, and you can see it here under the output. So using entities, we have just created a smarter bot which is a little more user friendly, and in the similar way you can use multiple entities, multiple combination of entities and intents to make a really smart bot. So we have just used one entity here. You can use multiple different entities and then use them in a very smart way as per your business logic. So that's all for this session, and I will see you in next lecture where we will add Q&A maker and make it a little more intelligent.